Um, Good afternoon, everyone. Ah, I beg you.
Can't smile.
Oh,
Can't wait. Can't smile in class.
okay, so while we wait for those that are not in class yet, um, we'll basically be trying to design our circuits, right? We've heard all the stories and the theories and the what again? Plenty things, right? But now, like, how can we think about it with respect to code? So for now, we're going to start with like our circuit representation. How do we want to represent our circuit? How are we going to represent? For now, we're not going into the prover side and the verifier side yet, right? Just the circuit. We want to design our circuit and we want to be able to evaluate our circuit at any point. Right? We want to give our circuit a set of inputs and it spits out an output.
Now that circuit,
Yeah.
that circuit now, I know there's a process called arithmetization that gives that circuit. So that's not what we are doing, right? What we are doing
No.
is we know the circuit
Yes.
and we just want to analyze the circuit.
No, we want to design the circuit.
We want to
So we want to design the circuit. You get. So there's, let's say, maybe a language like Secom now. You may write Secom and then compile it down to your circuit representation, so that you can now prove and verify it. But now we're not talking about like the whole writing Secom and compiling to it. So we're just talking about us basically writing, like defining, how can we define our constraints, right, for the circuit. Like, how can we define each gate and what the gate should do. I don't know if that makes sense. So that when we pass in two values, say we have a gate, when we pass in two values for the left and the right, it gives us the output based on what the gate is. If it's an addition gate, if we pass in 5 and 7, it will give us 9, right? If it's a multiplication gate, if we pass in 5 and 7, it will give us 35, right? So like that's what we want to do now. We want to like design that structure. Does that make sense?
Yeah.
Okay. So what is it even going to look like?
You know already.
I don't know.
Are we going to pass in the gates too?
Yeah?
What are we passing?
Okay, let's start from like, basically a layer is made up of gates, right? So we have a layer, let's say this layer. And it gives an output. I can call this a layer, right? Right? So it's made up of gates, either an addition gate or a multiplication gate, right? So what should we start from? Like, in order to define a layer, we need gates, because we cannot define a layer without having gates already, right? A layer is made up of gates, right? So I think the first thing we even need to talk about is how can we even define a gate, right? Right? Okay. So what's a gate going to look like? We know that a gate should have an operation, right? it should have an output. It should have, let's say, left input. Is that left? That's left, right? And this right. Is it? Okay, so
But some might take more long.
huh?
Some operations can take more long.
Yeah, some operations can take a while, but for now, like even some gates can take in like five inputs. Yeah, some gates can take in one input, right? But for now, we are just dealing with a fan in two gates, right? So fan in two simply means it takes in two inputs. But it's like when it takes in those two inputs, it's going to do something with it and then spit out an output, right? So they can be fan in three, they can be fan in five, they can be fan in whatever, fan in, like fan in. I don't know if there's an apostrophe or what is that? English. So fan in, you get. So I was talking of like the input. So it can be fan in two, like what we are going to be talking about, or like what we are going to be designing today, and there can be fan in any other thing. So now we know that our gate is meant to have like an operation, right? Output left and right. How can we represent something like this? Is it a difficult question? I was expecting everybody to be chanting. Okay, so a struct. We're going to call the struct a gate, right? Anything you want to call it, you can call it gate. Okay. It's going to have 4 fields. Okay, so what's the first one? Left. What should be the? Okay. No, don't worry. We're not writing code. We're just designing.
I think the output should not be fixed. It should be like a function like a reform that returns that output rather than fixing the output as part of the like we don't need
The output.
or it might be
Can it be?
Can it be like part of the STP ops? Like, you know, ops you have cross so
Are you like you want to override the? I don't get it.
I'm not like when the operation is closed, you have cross.
Yeah, it's just addition, right? It's just addition.
This one is just
Yeah.
addition.
So your gate, you're still going to be. You need to be able to evaluate your gate too, right?
Yeah.
So our gate will probably have a function to do that. Probably. I don't know yet. But okay, so we have a left, we have a right, we have a what again? Output and an operation. Okay. Interesting. Do all of us agree? So we have a left, we have a right, we have an output, and we have an operation. Okay. So basically for this layer now, we know we have like 2 AND gates and 1 MOR gates. That means we are going to have like 3 of this structure. Right.
So it's not really just
when you mean output
everything.
and operation, I'm getting confusion. So what is the operation? What are you representing as the operation? Because I think when we said the output and the operation is still maps to the same thing.
That is the label, right?
Yeah, the label. So what are we passing in that?
This operation can be an addition operation,
Like how
right?
will it be? Is it
How we represent.
How will we represent it?
You can use the string. You can use the string instead.
I don't know. I don't know how I represent it.
Because it's like words.
Eh?
We find that
I don't know how we represent it, but we'll figure it out. So let's just take it slowly. So we have a left, we have a right, and an output. This left, right, and output is the labels, right? Right? So if we have like, let's say left of 0, right of 0, okay, right of 1, and output of 0. What's that going to look like? That should look like, let's say an addition gate, right?
That would be one.
That's all. Output of 1.
Yes.
Yeah.
Those
It doesn't. Why output of 1, sir? No. We are not talking of the. We have not passed in inputs to the gates yet, right?
So how do we now have an output?
It's just like
Yeah, like a gate takes in inputs from the input array, right? So that input array, we need a way to pick values from that input array.
This gift that we're building now is for that stuff, that add gate that we
So
that one that we're passing in output.
this one, right? Oh, sorry, network is. Okay, so this one, right? This is what you're talking about.
Not this one.
Sorry, which one?
Like that, before this presentation now, we had a gate that received output, input, and then returned either 0 or 1. Is that the gate we are building?
Yes, that's the gate you are building. So okay, just
That
help
means
me.
that
Let's draw the gates.
Confusing with this
That gate you're talking about, can we draw it? So it's
receiving input,
yeah,
then receiving output as input.
something like this.
Yes, with one extra input.
We want extra inputs.
Yes, that is the output. Output label or something. It
Wait.
has BC, then it has one more.
BC, and here is A, right?
Yeah, but then it has one more this thing, one more input, which is
What is that?
talking about we having two layers.
that's the
W something.
yeah,
Is it the
because
W?
something add I, there's XI, there's B, then there's C. So this is the B and the C. Then the XI is like, I think the XI is like the output.
Next are the level.
No. A is the output of that.
Yeah, A is the output.
Yes,
Then
that's
B and
zero.
C are the inputs,
Yeah, but there's
right?
one extra.
Wait, okay. Let's think of it in terms of. Let's forget about A, B, C now, right? Let's think of it in terms of numbers, right? So let's say the output is 0, right? Then this is 0 and this is, or let's maybe this a gate. This output of 0 is 0, 1, right? This is another gate. This output of 1, right? This is what? 2 and 3, right? Another gate. Sorry, what is the first gate? Let's call it an addition gate, right? Multiplication, addition. This 2, 4, and 5. Is this what you're talking about? Not this.
So what gate are you? Is it a generic arithmetic? Is it a generic gate or
Yeah, it's a generic gate. Like, it's a gate that we can. Wait first. When we are talking about a gate, like, we understand what this is, right?
Yes.
What is it?
this is like a normal gate that is through gate and gate and out gate?
Right?
Yeah.
What does the zero here mean?
The output.
The output. But what about the output? Does it mean the first output, right? So if we have an array here and an array here, and we have a set of values in this array, give us random values.
2, 4, 6, 8,
2, 4, 6, 8, 10, 12. Like, right now, we are trying to evaluate this, let's say this layer. It's when we want to evaluate the layer that we give it concrete values. Is it making sense? Hey, voila. Are we following?
Yes.
2
Sure.
and 3.
Yeah.
How will it
Wait.
become 1?
That's the label, not the value.
No, I'm coming. So, is everybody, are we together?
Yes.
Sure? Let me remove this guy again. Like, are we comfortable with this, with the representation of this layer this way?
Yes.
Yes.
Well, we are comfortable with it. What does this zero here mean? Let me ask it again.
The label.
It's a label, right?
Yeah.
What does it entail about this addition gate?
It's looking like that place is like an array, so it's telling you the position of the array.
The position, right?
Yes.
So any value we take in, when we are returning the output, we are going to put it at the zero index of the output array. Is it making sense?
Yep.
So this is an array. This is an array. Right? This is our input array. 2, 4, 6, 8, 10, 12. Right? This is our input array. You can call it the WMLE, right? For the input. And we want to evaluate this input on this layer. If we want to get values from this input, how can we, okay, if I want to get the number 6 in this input array, it's at index what? Index 2, right? So basically, what are the values that this gate takes? This gate,
2 and 4.
it takes 2 and 4, right?
Yeah.
So it's just using the label to index.
Yeah, I get it now. So now we 2 plus 4, 6. 6 will be in the 0 to
Exactly. You get it. Does it make sense now? Are we sure? Are we sure? Are we sure? Oba, are we sure? Okay, so how about this multiplication gate? What values does it take? 6 and 8, right? And 6 times 8 is what? Is it 48? 48. Okay. And how about this last one? 10 and 12. So that's 22. Is it a must for this guy to be 0?
No.
Okay, let's forget about like the inputs and the output. But is it a must that whenever I have a gate with an output, like that is 0. Let's say this is an addition gate. If the output index is 0, is it a must that this guy must be 0 and this guy must be 1?
Yes.
Is it a must?
No, no.
You can pick.
You can choose to label it with something.
You can choose to label it anyhow, right?
This will be minus this.
Huh?
But if it was supposed to have different
Sequential.
arrays to them or to pass in the left, right, the left, right, and out the different input arrays to like input them into the function.
No, for now we are just forget about this guy for now, right? And this guy. Okay, so you said, is it possible for us to?
For every layer, have
Yeah.
the left and the right in different arrays. So like they now store them in the structure.
Is there a need? Sorry. Sorry, let her. Okay, so you're saying like we have
Left structure, left array and right array.
okay left array and right array. Okay.
So now I'm on 2, 6. Okay, right is 4.
Okay, no, like for now we are not even concerned about this guy. We don't even know this guy. Right? We don't know this guy at all. We don't know this guy. We are just designing. This is the guy we are designing. Does it make sense? So when we design these circuits, you can decide to pass in 2, 4, 6, 8, 10. You can decide to pass in 1, 2, 3, 4, 5. You can decide to pass in anything. You get. Then when you pass in that input, based on the labeling of your gates, then it's going to pick values from that input layer and then evaluate. But that's when you're like evaluating or you're running your circuits. So it's when you're running your circuits that you pass in concrete values. When you're running your circuits, that is where this guy actually matters. Right?
Yeah.
Is it making sense?
Like for the structs, like initialization, right?
Yeah.
You are just initializing with the index, right?
Yes, just the index.
Just the index.
Yes.
Now for the operation, like
But we're coming to the operation. But does it make sense? Are we sure? Like when we are initializing this gate, we are just telling the gate how to pick values for the input. We don't know the input as at that time, right? But whenever anybody wants to run the circuit and the person passes in a set of inputs, based on the gate label, it will now pick the right values for the inputs.
Those values, initial values you just just like indexing.
Yes, just indexing. Yes. How do we want to index our array? I don't know if it's making sense. Let's just look at, say, so let's say we have a gate, an addition gate, right? We want to define this gate. And we say the output of this gate, store it at index 3, right? And then pick values from index 1 and 7.
seeing this inputs now, instead of as values, we are seeing them as index.
Yes, they are index, not values.
How about when you say that instead of us trying to I know that for every second is our right, for every second value is our right. What if we have like the same array of the same length, so going to be our left, our right, then our left, right, and so this gate can be index 0, the next gate can be index 1 for every left, right, and output.
Okay, let me just, like you said, a left array, right?
Yes,
And a right array.
yes.
Okay. Then,
And for the first gate, for layer, the very gate, the
so this left and right is still like, we're still on like layer 1, right? Okay. So for the, like, in the left,
yes, and which will be same as the right and same as
this way,
the
2, 3, okay?
then right is going to be
0, 1, 2, 3, okay? Then output 0, 1, 2, 3.
And if now want to rearrange, maybe we need our if we need our left and right to be like the same evaluation of that number, we can now rearrange like the meaning is that bigger array, we can now make a bigger array
Okay.
that's going to take in the second
This representation, it's if let's say we have a layer where there are like 8 left and right.
yes.
You understand? So and you're representing it like this. How will you array it? You have like an array of left and right, left and right, left and right.
No, you're not. If you need it, in this way, you can easily rearrange it into a bigger array and to be your layer. I'm just thinking
Okay.
when the user wants to input it into a function, like you want to find the layer function, how would you represent it? Like, am I going to be thinking of this? I have to have a second and I'll pass it to can I? Is it going to be left into like say left, or right, or maybe if it's going to be that I take all the values on the what's it called, on the layer. I mean that's
Okay. No, like for now, let's just think about like just one gate. You get? Okay, I think like you're thinking about like the layer as a whole, right?
yes.
Okay.
It depends on I feel like the
It will be better that way.
But I from what she's saying,
Wait, you feel it will be better that way?
it depends. If they are able to work.
we want to look at what she's saying. I think it will be like more like a sparse representation whereby you have an array of tuples. So the first tuple will have 2 values left and right. So if you have an array with 1 tuple, you know that it's just 1 gate that is there. If you have an array with 2 tuples, you know that it's 2 gates, the left and the right. The first tuple will have 2 elements, the second will have 2 elements. So you know that okay, this array has 2 tuples and one
Okay.
tuple represents 1 gate left and right, the other tuple represents the second gate left and right. So if there are like 6 tuples in the array, you know that there are 6 gates. So each tuple representing a gate with the left and right values.
Okay.
Yeah, for a particular layer. So if maybe you are dealing with a layer with just 1 gate,
So it's
you
going to
understand,
be
you just
like
have an array of 1 tuple
Of one.
left and right.
that's
That's what's true.
okay. Okay, how about like the operation? How can we
How can you put the question is?
no like how can we represent like the operation?
What comes to mind is if you have a symbol, maybe a symbol, if you have a symbol plus, or if you type in cards,
Okay.
Match it. And I don't know. That's what comes to mind. I don't know.
Can I ask you now?
Like you may use plus or add.
Plus, and like when the user passes in like the addition,
Yeah, you perform add functionality to that match add or match.
okay. So like, do you have an idea of like what it will look like? Let's say we want to add now, right? So we match on add
Yeah.
on the add
If
string.
you see add, then it's not performing functionality like not add. Then if you see
So how will it pick the values like to perform the operation on? Like we now we know that it's add, right? So like how can we now pick like the values?
no, I feel like this is going to be easier. And if you pick the first index in every array for this one, right?
Okay.
For the right and left.
Okay.
First index, then the second one, work that it's goes on like that.
Okay, so basically we can say that this first index is an add gate, something like that. Then the second index is a multiplication gate. Is it something like that?
Yes, technically the one.
Okay. So if we have like an add gate again,
We are trying to, I think we are first, are we trying to store in this, we are trying to store this thing in the structure, right?
yeah.
Yes. So now this is how you store them in the structure. When you have the add, store it in the put the add functionality in the structure. Like if you have the location, put that in the structure. I think that was
Like destruct.
yeah, that was transfer, store it in the structure.
Okay. Okay. So like will this still be a single value or an array now?
It should be a single value.
Okay, it will be a single value.
Like you are taking them and putting them in the structure.
Okay. Does everybody like understand? Okay. Okay. So we're trying to design what our circuit should look like. Right? Yes, code. Right. So
The struct gate is the struct gate. What is it supposed to
you know, like we're trying to design what our circuit will look like. Our circuit is made up of different layers, right? And those different layers are made up of different gates, right? So we're trying to think of a good way of representing it. Right. And initially we were like, okay, let's focus on a gate, right? Since every layer is made up of gates and every circuit is made up of layers. So I was trying to like go to the the barest minimum, right? So now design the gate. And the initial idea was that we define a struct, right? We call it a gate, and this gate is going to take like, basically we know how a gate looks like. This output, this left, this right, and this the operation. So our initial idea was that we are going to have like an output, we are going to have a left, we are going to have a right, and we are going to have an operation in this struct. So when we want to create a new gate, we just need to do like gate new, right? We pass in, yeah, we pass in like for the output, we pass in values for the output, pass in values for the
What
left,
will be the
right?
representation of the operation in like the time for the operation?
Yeah, like for now we've not talked of the operation yet, right? But the operation can be like a string, right? We can decide to make it a string.
A string.
We will not
Can't it be an array of
You will now, yeah, we can now pass it.
or it can't be an array of string.
For the operation,
Yes. Then
Each-
we pattern match
each gate has just one operation, right?
it. Yes.
We're talking about a gate now.
Yes, yes, yes.
Each gate has one operation. So is there, so why make it an array?
I don't know, so the operation can actually be like your multiplication.
Yeah, so when you're creating a gate, you're going to pass in, like if it's an addition gate, you're going to pass in
I don't know, sir,
an
like,
addition.
yes, like the way I'm looking at it. Probably if, like there's an, I don't know, if there's an option to pick the operation, then we now match it. If it is plus, then
Okay, like making it an enum.
yes, something like that, yes.
Okay, I think that still works. You can make it like an enum. You can make it a string, right? Yeah, you can even use a char, like you can use anything to represent the operation.
I
Okay.
think, a more generic way to represent the operation. So inside that stuff, we can have more. We can have add, and we can have more.
As
So
okay.
yeah, add and more. So for add, it will be a bool. You understand? Or we can either, if we don't want to use a bool, we can make it U8, whereby we set add to 0
Okay.
and more to 1 if it is small at that instance, and if more is off, we set more to 0 and add to 1. So we can either use U8 to use numbers to turn it on and off, or we can either use bool to do true or false. So for a point where add is false, we know that more is true at that instance, and for a point where more is false, you know that
Okay. Yeah, I think that works too, right? Yeah, that works. Okay.
We only have two types of gate, that's add and
more.
We can have
for
for now. We can actually have like other gates too, like a subtraction gate. But we get the idea of a gate, right? It takes in inputs, and based on the operation, it does something.
But I think the reason why we can look at it as more than add is because every subtraction operation is an addition operation.
How about
Basically,
okay?
and every multiplication operation, every division operation is a
It's a
multiplication
multiplication.
operation. So if we say like 1 minus 2, the same thing as 1 plus minus 2.
But like there's what they call custom gates. You can have a single gate that can do exponential, right? You get, so you can have a single gate that can do square roots. You get, you can have a single, like they call it custom gates. So the gate may not just be doing like addition and multiplication, it may be doing like some complex operation. You may decide to have maybe a cos or a tan gate, depending on depending on what you
So
want to achieve.
I think with this representation, if we're able to like clearly label the gate name like add or more, that way if we want to add any other gate, we can
can
either
just
add
add
the
it.
gate there, and so anytime, let's say we want to add an exponential gate, we can just put exp there. So
Yeah.
it's either be on or off, either 1 or 0 or true or false. whichever way. So anytime
Yeah.
that SP gets 1, you know that exponential is turned on at that point, so we are using it.
It can be like basically what you're trying to drive at is that it can be an unknown, right?
Yeah.
Yeah.
And we just keep like adding different types if we want to increase the number of gates, right? That works, right? But the idea is like, is this representation okay?
Sparsely.
For simplicity, yes.
Okay, because like I've not fully grasped that your representation, but I wanted us to also like go through it and see like if
That's what I'm talking about. I think I want to layer implementation. Because we're talking about like so like as another layer. So I thought we were talking about that already. So that's what I'm
Okay.
saying that. Now if you want to represent a layer, you need to be maybe like the gates, the breadth of gates okay, for a layer.
okay, that was why like the tuple stuff, right?
Yes.
Where we have like for a layer, we
Yeah.
have a tuple for a gate,
Yes.
the left and the right. Okay. Maybe like a tuple of 3 elements, left, right, and output.
What I was thinking was like the breadth of gates, like the breadth of this set of gates. That's we don't have to think so.
Okay. So like what she was driving at was that like for a layer, although we've not gotten to the layer this thing yet. Or like for a layer we can have a vec of tuples, like an array of tuple, where in each tuple we can have like the outputs left and right, so it's basically still this information in our struct, right, but we're representing it as a tuple. You get, if I got you right? Okay, so I think for now we can just like stick with the struct representation. Yeah, but like everybody can as well like implement it different ways. You know, this is just like a design session to expose us to say ideas that we can explore while implementing. But hope like it makes sense up to this point.
Yeah.
Okay. So for these gates now, the values it takes like when we are creating it, I was trying to explain that is basically the values it can use to index the input array, right? So let's say we have a gate like this, an addition gate. I think we had one example here, 317, right? We have 3, 1, and 7. So what that means is that if we want to evaluate this gate as a set of values, that array that we are using to evaluate this gate must have up to 7 elements, right? Okay, let's say we have another gate, 0, 0, and 1. This is the gate we are conversant with, right? What I'm trying to say is that it must not always be like this, right?
So it doesn't mean that this 7 is the index, right?
Yeah.
It looks like 7 is coming from another input. You don't normally like
Okay, let's say we have let's just make it 5, right? These are two different gates, but we're passing it this input. What values will this first get? This is 2 and 4, right? And it will output 6. How about this gate? 4 and this 0, 1, 2, 3, 4, 5, 6. 4 and 12. And it will output 16, right? But still, like in this output array, let's say we have 0, 1, 2, 3, 4, 5. Right?
So, how do you determine the length of your output array? Do you just put any length for the output? Array.
For the output,
Yeah.
that will depend on
The label.
the number of gates, right?
Because
Because every gate is giving out one output, right? So it will depend on the number of gates. I don't know if that makes sense.
Was it possible also have like
Like very right. What do we have nested layers?
No, it's just one output. Then any this thing, like if it's going into another gate, that gate can feed from it, right? It's giving out one output, but
for how many inputs?
yeah, irrespective of how many inputs. So based on this now, where in this array will 6 be? At index 0, right? 6 because of this. How about 3? How about 16? It will be at index 3, right? Is it making sense? So when we are defining our gates, we are basically just
That's 0 and 3, the index. Did you put them at
yeah, they were just random, like
Why
it's
would
an
you want to
example.
why would you want to do it like that? And not follow the
It's an example.
So normally,
It's an example, just a random example.
exactly. So if I were to represent this, it's going to be based on the length of the array. So it's going to be zero. It's going to be at zero, then two, 1 because of the length of that.
But
Because we are already giving out two outputs now.
yeah, that's what it's meant to be. But I'm just like, this is just an example for us to know that like the output we can decide to put it anywhere, right?
So we can control that.
Yeah, we can control that. Basically, when you're creating your gate, you're the one that will be passing in these values for the outputs left and right. I don't know if it's making sense. Does anybody have any question? Alpha, do you have any question?
Yeah. So I'm question.
No, I'm asking, do you have any question? Yes.
From his question, you can go back to the question I've made. And that's the big part I need.
Like, those at the back, are we even paying attention? Huh?
I'm not among those at the back. Yeah, there's fans that watching
Okay. Do we have-
So now you're saying that based on the inputs you have, let's say the array is one. Say maybe 12 or something. That's the multiple of the because you're adding like your gates is like taking 2 gates.
I'm like, I'm not going to write the code for you people, right?
Yeah, and what I'm just saying
Yeah.
is is it right to say that the output, the length of the output is going to be half of the length of
It may not always be the case.
why not?
It depends on how you design your circuit. We can have a circuit, sorry, we can have a circuit like this, right? This is still a valid circuit.
Yeah. So but then I think we're talking about a layer.
Yes.
So just for the first layer that you're doing first of all,
To get
to get like what you do now is just the first layer. It's not like the whole circuit. We're doing like the first layer. So for the first layer you have input and output. Which is all we
yeah,
have.
every layer, like it's code we are writing, right? And when we, sorry, I'm calling. Like it's code we are writing, right? And when we, let's say when we define these things, even if we define it for one layer, we can still use it for another layer, right? So like defining it for one layer does not restrict us from using it for another layer. Since you're passing in the input and the output in the create function, right? So the thing is that, like, we're just creating a generic structure that we can use to create multiple gates,
Like,
irrespective of the layer,
The layer, the output,
irrespective of the
Let
output.
me just get this straight. So it means that every the input, the output, everything is just going to be index based. So it's going then we have the input. So it's going to just be picking from those. whatever
Exactly.
It's going to be picking from them.
Yes.
The operation is going to be picking from the if you're using it's going to be picking, getting that because
Yes.
operation.
Yes. So when we define a gate, we are just telling the gate where to pick values from. It doesn't care about the layer itself. A gate is taking in inputs and giving us an output. The layer is not.
we're dealing with it like a different, like its own level of abstraction outside of it.
Yes.
Or we can visualize this time when we put this one.
Yes.
This is what it's on this time.
At this time,
So,
exactly.
if it receives that, so we're looking at it as an input now, which is just sort of a layer. We're looking at it as just an array
Yes.
or a vector, whatever it is. So now we know we are dealing with indexes here. So if there is no, let's say if the gate is supposed to receive an index 7, and then there is no index 7 in that array, so does it fail or what?
It should crash because you're telling it to pick values where values does not exist. Right? So that's a problem.
But then why is the index of the gate fixed?
It's not fixed. You're the one that is defining it. When you create a new gate in this new function,
So we're supposed to pass in the index. Like,
you
so
pass
that-
in, yes.
Okay.
So when you're creating a new gate, you're the one that knows like the inputs that you want the gates to take, right? So when you're defining a new gate, you pass in those like this outputs, left, right. As if I'm writing code for a people. In short, I think eh? I think we are done.
No, you're not writing code for us. So.
I'm writing like what do people want to now go and do again now? Eh? No, now we're writing Rust already now. This is gates column new.
But the new is not complete now. There's no.
We can go, right? Thank you. So people should
So what are we doing? What are we doing? What are we doing?
we've defined a gate, right? A layer is a collection of gates, right? And a circuit is a collection of layers.
Okay.
So,
So I finished.
So what are we doing now?
So what are
Eh?
we to do now?
What are we to do? The
Build. Okay. Build a circuit. Right. Give that circuit. After building the circuit, you're going to like define what you want a circuit to look like.
We are building a circuit.
Yes.
Wow.
No, you're building a circuit.
What is it?
We've talked about how to build a gate.
Now, a layer is a collection of gates, and a gate.
And a circuit is a collection of layers.
How you laughing?
Right?
How you laughing?
That's supposed to create a circuit.
A circuit is a collection of.
No. Okay. Let me just give people an interface. Right? We are going to have a gate, just like we've defined. Right? A gate. Right? We should be able to create a new gate. Does that make sense? After creating a new gate, okay, let me just.
You should have a layer.
Yes. You should now have a layer, right? And a layer should be a collection of gates, right? Then we should now have a circuit, right? And a circuit
Be a collection of layers.
should be a collection of layers. Is there any other thing to explain?
That's finished. That's the.
Eh?
That's the.
My question.
I have a question.
All of these
Wait,
layers
sorry.
that
Yeah.
we are saying, collection of layers, are they going to be the concrete values?
No, not the concrete
Is
values.
it the indexes or is it the Boolean whatever?
Like, is it for the circuit?
Yeah, for the circuits, for the layers.
No, like everything depends on the gate, right? And what the gate takes in is basically indexes, right? So once the gate takes in indexes, you have built your circuit. So wait,
Where is the concrete value? Where is the concrete?
okay, that's what I want to go. That's where I want to go now, right?
How do we get
Okay. Okay, so we've defined our gates, we've defined our layers, we've defined our circuits. On our circuits, we should be able to evaluate a circuit, or we should be able to run a circuit. So we should have a function like circuit run, or circuit evaluate, or circuit.
So at what point should we be using this? This is our formula we can go to.
Oh, we've not gotten to that
To that
point.
place.
We've not gotten to that point. So, what this run or evaluate or whatever thing you want to call it, what it takes in is actually a a vector of it takes in an input, which is a vector of what?
The value.
The values. What particular? I need the type of the values. Exactly. It takes in an array of field elements, and based on our circuit definition, it should give us an output.
Not just output. Not just output. All the intermediate.
Yes, and not the intermediates. Yes.
Remember that you are going to create W1, W2, W3. So you need those evaluations.
Yeah.
Also arrays.
So at
An array of arrays.
so at every
Our
layer,
layers,
Yes.
you know, in the course of class explanation, we label
We have just 6 minutes.
yes, now let me
Okay.
just in the course of our class explanation, we label our layers from the last one. That's the last one, that's the output, we label it W0, and
Okay.
the beginning we label it W3. Now I want to ask, in our circuit where it's a collection of layers, our labeling, is it supposed to be the index of our labeling? Are we going from lower to higher or higher to lower? Like,
We are going from uppermost to lowermost.
because
Okay.
the input is this guy, the main bottom, the regarded W3. But if that's the input, that should start from our layer. That should be our layer
Layer
0.
zero, yeah.
So that would be our index 0 building up.
It's just words, it's just link.
Exactly.
Yeah.
I don't think
Yeah.
it's
So
thinking
it's just
of it.
English, use whatever you want to use. If you
So
want
what
bottom
we
to
have
be
there
zero,
is-
fine.
Let's
You
not
want
do
to
the
be
wrong thing now.
There's no
So
wrong
there's no
there.
wrong there.
So this
So our
second one is starting from
layer
the
like
top,
this
right?
one. So this
Huh?
our second one.
From bottom, like building from
The different layers
Circuit.
in the circuit. It should be dependent on the number of gates that are in the layer, right?
You need to know now. We are running the second.
Ask your questions.
Yeah, you can just make it a vector so I can just be pushing it.
As it goes on,
Yeah, as it goes up, it reduces. As it goes up, it reduces.
they don't even want to mind.
Why am I here? I have gate. I just have the gate. This is the layer. Then has the gate. Then each gate counts right.
Left and right.
There are multiple ways.
Like there is no.
There's in the way
I think when they start implementing, it will start making sense, right?
there's a way to do this thing, This is how like prod systems do it. Where they have gates, right? And then you can now attach another gate to it. And then there's so like you have a gate. The gate is like an entity. It's like graph. You can now like attach, let's say a left node or a right node. Or you can attach two nodes to maybe like same parent or something. So what you're doing is instead of building it like this, where you already know your layers and everything, they build it by building like a directed graph. They just attach nodes wherever.
There will be layers again.
No.
No.
But then it's not, we need to be layers.
It will now be irregular, right? Yeah. Then we'll now do the processing on it to convert it into layers.
I think they use that in ML or something.
You can use that in ML.
The operations, are we going to do them? What operation?
It must have multiplication.
That's what I'm saying, are we going to?
Yeah, you draw a circuit. Then you have a way to write like a drawn circuit in code. So you can just like write it. But you guys will be fine.
With the layer
Yeah, you'll be fine actually.
am I to do those with the layer?
No,
Huh?
you can't. You should
Yeah,
be able to handle
you'll be
as
fine.
many layers as possible.
So,
Not just 3.
Actually.
If you want to do 50 layers, you should be able to write your circuit builder should allow me to use it to like write a 50 layer circuit. And I should be able to write one that has maybe like 5 outputs or 6 outputs or whatever. It's just like making generic. This is just circuit.
It's just swap.
No,
I'm not started
just
the
want to
project
get
for.
Yeah.
Yeah. Okay, yeah. Actually, you can use that as your test, and if you get the output, you do it by hand, and then do it by code, like evaluate your circuit, then see if you get the same output.
Like there's a value for every intermediate node. In AI, that value is called weight. Yeah, it's called evaluation. But it's still like round evaluation.
Do we have any other question? No question, Abby. I wanted to talk about. No, it's just the art and the more like, because the approach that they want to go is well.
It might be hard for
Yeah, but it's well. let me allow them to.
Don't say you want
Eh?
I'm already settling you.
Eh?
Let's figure out the way this is supposed to be done, we teach you the theory.
Then you
And
figure
then
it
that's
out.
You figure out how
That's how
like,
it's supposed to be. Figure it out.
Because we are reading
Then if you have
papers.
challenges,
Papers are not going to tell you
Well, you guys used to be awake by
anything
like 5
in my
a.m.
interpretation. Huh?
You used to be awake by like 5 a.m.
You have to be serious. For sure. We'll reply you. For sure.
okay.
Let's try. Experiment at least.
We'll do it time.
This one shouldn't take us.
An hour.
It shouldn't take us 3 hours, right?
Try.
So the thing is like when we come tomorrow, at least we want to see what people have done so that we can help you. Like if there are corrections, there are things you need to change. We can like tell you better ways to go about it,
Nah, this boy is
right? But we understand the assignment, right? Write a circuit, evaluate the circuit on a set of inputs, and give an output.
And the intermediate.
Yes, and the intermediate values. So you're going to do it by hand, and you're also going to do it by code.
By hand, I'm just going to write down.
Yeah, you're going to draw it. So you're going to draw it by hand, and you're going to implement it in code. And the output you get when you do it by hand should be equal to the output you get when you do it by code. Makes sense, right? I don't know why we're wasting time. Should have finished since. Okay, so if you guys have any questions, maybe while implementing, reach out to us. We're always happy to help. Okay, have a great day. It's not weekend yet, so let's have a great weekend.